Hello, everyone. Welcome back to the Cloud Native live streams. My name is Josh Duffney. For this particular episode, I will be going through the Wasm By Example documents. I'm going to level set with you. I've not spent a lot of time, zero time actually, practicing and working in WebAssembly. All the knowledge that I have in WebAssembly and in Wasm currently is conceptual. So I had a conversation last week with a coworker of mine who's deeply involved in the project and kind of the things on the peripheral of that project of WebAssembly and getting it to run in cloud environments and so forth. And so I'm going to take this time to kind of work through the examples, and the journey that I want to take you on with this is, so in the documentation and the definition of WebAssembly, it's meant to be a compilation target. And so the promise there is you can build once or compile once, and then you can kind of deploy anywhere. And so I wanted to figure out like how that actually works and get some practical reps in with the coding with that. So the idea is that I'm going to start with building what I know, which is going to be a container. And a container, I'm going to show or figure out how we can build it for like AMD 64 or for the 60, like typical processor and then the ARM processor. And so I think with Docker Desktop, there is a way to do that. That's what we'll start with. And then what I'm going to try to do is, by the documentation and by the examples, I'm going to try and figure out how I can get that to run or compile to WebAssembly and then run on different architectures. And I might not get all the way there because I'll probably need, in hindsight now, I'll probably need to get a different host for the ARM deployment. That way, because Docker would mimic that. But that's what we'll start with. So I'm just going to jump into the code. We're going to figure this out. There's going to be a lot less talking in this episode. A lot more thinking, so please feel free to chime in the chat. A lot of these sessions are meant to be just, in the name, the pair programming. So as I go through things and I think through things, if I stumble and you have answers, put it in the chat. Meant to be kind of a more engaged conversation than necessarily me talking at you. So I welcome all comments. So with that, let's dive into sharing the screen and getting some code written. There we go. All right, so I'm not quite sure how that looks. So if there's anybody in the chat, can let me know. But I will probably just make this full screen and zoom in a little bit just in case it's small. Always better safe than sorry. So here what I want to do is I'm going to create a new package. So I'm going to use NeoVim for this to start. And I want to create a new file, and we'll do main.go. So what I first want to do is build a Go application, probably just using Hello World or something like that. And I want to compile it to run on two different architectures. So I'm going to have to use a base image that supports both. I think Alpine would probably be one of those where they have different tags. And so there's literally different images, but then there's something called an image index that is able to determine what architecture you're on, and then it'll pull the appropriate image. So it's a way that you can run on multiple architectures with containers, with Docker, with a single reference, single tag and name for the container. So to start, open this up, and we'll just do something really simple to start. Hello world. Only need func. I'm not sure how I'll get this to work in WebAssembly yet, but well, now this is the starting point. So function main. We'll just say func print line. Oops. VS Code too long, and I'm starting to forget my shortcuts here. Hello world. So now let's figure this out. We'll just make sure it runs. We get hello world, which is cool. Now I want to figure out how I can create a Docker file for this. I think I have some examples on my GitHub. short URL object that might have a Docker file? I don't think so. Well, first, let's look at Alpine. Maybe even some Go images that I could use. Like I mentioned before, I want to be able to run AMD and ARM. So Alpine definitely does have those tags. Oh, I can cheat. Let's think through this. So the way that I could cheat is I could compile the binary and then just include that in the image, but I probably want the Docker file to build it as well. So that would be like a multi-stage Docker file where one stage of the build builds it, and then the other stages will puts it into the container, the binary that's going to be executed or built from it. That's a good question. I don't know if I need to do that. I really wonder what I did, what project I did the Docker file in. Maybe there's a branch. No. Because I know I've built Docker file with Go before. Well, when in doubt, we can ask the AI tools now. Yeah. Let's see how close it gets. So build a multi-stage Docker file for Golang project. Try it out. See what it's doing. So Golang, there's an image Golang. Let's check that out on GitHub or Docker. And see if it has ARM support. Oh, I just remembered. It does. So use that. But I think I just remembered where the Docker file that I wrote was. Hello. Images. Package metadata, that's probably what it was. So I was working on an issue. Oh, hey, Matt. Just saw your message. Thanks for joining, man. Good to see you. All right. So I was working on, I didn't get very far in it, but it was trying to figure out how to get package metadata into a container image that uses from scratch. The long short of that is you can't. And you should patch upstream. That makes sense to anybody. But if let's see your package metadata, let's open up the Docker file here. And this should look pretty similar. Okay. So kind of the same, but not exactly what I was looking for. So let's switch back in here. what is the latest version of Docker image? I guess we could just use latest. That would be fine. Folder, create a working directory, copy, mod and sum, download, then build. And if I was to make this work, I'd have to make a sample web application instead of a CLI. So I don't know if I want to do that. What if we tell it? What if we give ChatGPT this? Ah, okay, so that would work. That would work just like the Calico CLI thing. Let's delete all this, paste this in. And then we'll just have the entry point. We don't need to expose 8080. Because really all we want to do is create a Docker file that builds it and then takes in the compiled binary and then runs whatever the hello world is. So latest build hello world. So yeah, well, I don't need any of that because I've created a Go mod or anything. Not downloading anything. While that's loading, I wonder what are the Docker build commands for building as ARM. Because this is all stuff I've done, but it's been at least a couple months. So it's all kind of escaped my brain. I'm pretty sure that there we go. With the build X command line, there are some parameters that you can pass in to change the architecture. So let's see where we're at. Failed. Okay, I don't wonder if I don't even need that. It's pretty simple. Does it need to say Linux? Just come in here, go build -o my app. And then if we run, it works. Okay. So to remove that, we're running it again. This is going to build it for AMD architecture, because that's what my host machine is by default. But with Docker Desktop, there is some kind of a shim that will allow you to compile or create a Docker image for an ARM. It is slower because of all the virtualization that it's doing, but it's possible. So I don't need another host to be able to compile that. I don't need any of that. Run. I probably need to copy in the files though. Copy in the main working directory. Do slash app. But if we always harder to code when there's a camera on you, but I'm getting a little bit more used to it. In the image, we're going to copy in the main Go file and set the working directory. App. Well, that's sad. I see 3, so at least 3 are counted. I know you're here, Matt, so that makes me feel better. Okay. What if we don't have a working directory? I don't really care about it. Still not like, oh, maybe is Go build not on the GoLang image? I would imagine it would have to be. Did not complete successfully. And bash. Oh, I need to do gmod in it. The world. That's something that always trips me up with Go is the mod file, and always having to create that. I'm very used to interpreted languages, where you just have a file and you just run it. So now didn't work. Go mod. Save. I did that previously. So now that we have a mod file, maybe build command will this. No. Jesus. What am I missing here? Okay. Let's look at an example for that. Maybe it's wanting me to put it in a special location. Let's try this out. Working directory, user source app, some file. Oh, maybe. Yeah, it looks like the example could call Matt. Maybe it does need to download, even though it's just using the standard library. Maybe it is that what creates the sum file? How is the sum file created? Because that's what it's complaining about here. Directory. Let's see what this says. Mod under. Let's just run go mod download. Dependency modules, go mod verify. I wonder if it's not. Well, this is proving more challenging than I expected. I need more muscle memory here. When you need to copy in the files first, the compile your project, assuming uses go mod for dependency management. Oh, is that in there? Yep. So if we start from scratch, and here all I have to do. Okay, yeah. Feel free to share it. Could have a working example to go off of. Is there a link back to that? It kind of get cut off. I wonder if maybe I'll check Twitter and see. Don't see it quite yet. I'll keep back. I'll keep back and edit. Sounds good. I'll wait for the gist. Let's see here. It's not exactly what I want. So here, go. Where's the full? Okay. Oh, there we go. I can only show your comment, but I can't copy it. Let me see if it's on where that came through. If you wanted to send me that link in a DM too, that might be easier. Just a DM. Let's move this over here. Let's see this. All right, so here's the link that Matt sent me. Let's make that a little bigger. Do you know if you need the sum file? If it's just a standard library and there isn't one generated? Wonder where that gets kind of created from. Oh, okay. So maybe it just optionally uses that. I've only seen it, but yeah, larger code bases. So let's just kind of work through this. So let's set the working directory. Let's say copy the go mod, and then if this is working with go some for his particular project, hopefully it'll work for mine. And then run mod download. Copy. Just copy that one. Looks like a long one. It's your app, probably like a web app. Or it doesn't matter the entry point, but you should call it, or is it a command line? Does it output command line stuff? I don't know how much different that was from what I had in my first example, but so now we have that. Let's just do Docker run. See, my app is in CMD. Well, we'll see what happens. It is a web app, yeah. Right here, Docker images. Got a few, but there's the hello world. So Docker run, hello world test. Yeah, I'll probably have to update that. Might have to use entry point. It's just CMD. Let's give that a try. So to actually output as my app. So you're talking about, Matt, with like the .cmd, you're putting it in that directory. That's kind of a typical pattern. Line 11. And it's outputted like that. Yeah, because yeah, most of the pattern, you get your entry points under the CMD folder. Got it. Let's see if this can block if this builds. Build to create container shim task. Oh, I feel like this shouldn't be so hard. Let's go to Google. Well, I feel like I need to create more. I need to keep better track of my samples. That's for sure. Because I've definitely had to do this a few times. It should be a lot simpler. The problem is a lot of them are examples for web applications, which makes sense, you know, and I could rewrite my sample, but now I'm too far in and I have too much sunk cost and I have to figure it out. So if I have to take the time to do that, I'll continue on. But yeah, to reiterate, if people are just joining in late, you're looking great. Thanks, Tech Divas. Thanks for joining. To reiterate, my goal here is to be able to write a Docker file and a Go program, and then compile it. Well, build it into containers and then have it run on 2 different architectures to prove out that you need to have 2 different container images for that. And then so the promise of WebAssembly, which struggling to get to, is I should be able to just compile that one time and it run on both architectures. And so that's what I'm trying to prove out and test out. But first I've got to get it working in the things that I supposedly know, which is containers. So that's what I'm working on here. I think I found another better example for a command line. No offense, Matt. It's like super helpful on that. But for a command line one, I think we'll have to change the Docker file. So I have no doubt this works on your machine, Matt. If people didn't know, I should get the little fancy pops up. So if you want to repeat something and you have Vim or Vim, you can just hit a period symbol, period key, and not. I learned that one from, I think it was Mastering Vim, which is a good book. Still not my full ID. I've been spending the last week in VS Code and some of my muscle memory is bad. Hey, no worries, Matt. Thanks for dropping by. I appreciate the help and the liveliness in the chat. Talk to you later, man. All right, here we go. For CLI tools. Let's try Alpine. I don't think it matters much, but I like Alpine. I need to set the working directory. That makes sense. I want to copy everything in the current directory to app. That makes sense. So my go mod, go main are going to get put into /app, which is the working directory. Now I want to do go build out hello world, which will be the binary, and entry point. Okay, spell entry point right. And then, yeah, run the executable. That looks like it should work. And we're at the down. Pull down a new image because I'm changing it up. Super helpful when people chime in. Grateful for Matt for stopping by. These ones are the most uncomfortable for me because I haven't prepared. I'm usually very, very over prepared for all my presentations. And so getting used to live coding, even though this is kind of the deployment side of it, still nerve-wracking. But here we are. That built. Now if we do Docker run hello world test, now we've got it. So if we go back to Docker inspect, we could probably look at the architecture that this container image is using. So hello world is our test. And if you're really curious about the OCI and how containers are working, what Docker is abstracting from you, I did the very first series of 3 streams that I did for this particular playlist and channel was containers from scratch, where I wrote a container CLI. Let me just pull that up so you can see that. But what I did was I wrote a very simplistic CLI tool in Go that showed you, that kind of dove into the features on the Linux kernel of like what's going on when a container runs. And so I was able to do that and show how to create namespaces and stuff. So if you want to dive into that more, I'll put a link in the chat so everybody can check that out again. Or you can just go, you're on the channel right now. So if you just go to the homepage and see the playlist, you'll be able to see it. But I also, in I think session 2 or session 3, I dove into the OCI spec because I was toying around with the idea of making an OCI compliant image instead of just a blob that I had created. And that was super interesting. It's actually very helpful in the WebAssembly world as they're trying to define what the artifacts would look like. And so having a mental model for that's useful. So Docker, back to business here. Now what I want to do is confirm the architecture that this image is built with. Because while containers make all this code super portable, you also have to care about the architecture of the host. So whether you're running on Kubernetes or whatever else, it will use the packet or it will use the container metadata to determine which hosts in the cluster the application can run on. And that's one of the promises of WebAssembly that I'm working to get to is it says it doesn't matter what your host is, will run because it's compiled to binary. And then runs that way with a different runtime. So it wouldn't be containerd for Kubernetes or the Docker daemons. It would be something like Wasm time would be running it. So if we do Docker inspect, change this to hello world test. I believe in here, I should be able to see architecture. So I don't know why Tmux does that. I want to highlight, but it is AMD 64. So now I want to use the Docker build X command to make it a ARM, make it an ARM image. So let's go back. And here's the command. Docker build, and then essentially what you have to do is -- platform Linux ARM 64. I don't know if there's an equivalent like Windows ARM or anything, but in the image that we want to work with is our hello world test tag. I'm not going to push it anywhere. It's local. And the way that that's working for me, while I'm able to build on an AMD 64 PC, I think I have Xeon processors in this lovely tower of mine, is through Docker. It has some kind of virtualization shim that lets you do that. It's not fast. It does take longer, as we shall see. And it's not recommended. It's more experimental. I think it's in Docker desktop 1.21.4 you need. But nevertheless, we can do it. So once I get this working, I'll have an app. I'll probably switch over. I'll switch over to looking at the Wasm docs and just try to get something built and deployed. So I'm going to work through the tutorial to figure out how it is that you can compile to it. Most of the docs refer to TinyGo, which is a different compiler for Go. I would imagine from the name, it means that it has a smaller number of things, packages it has to compile are available. But I don't know for sure. I've never really looked into it. So that's what we'll dive into next. But I want to make sure this builds and I can run it on both. So built it. And I think we need to specify the platform when we're running it too. So maybe the run command has platform. Run. Looking to see if it has that platform. Okay. So Docker run -s platform. Yeah, here's the. I was working with trivia. I was doing this. I love how it preserves my history. because then it just proves we're right. Yes, I worked on this before. ARM 64. Bad. So the image that I want to work on is hello world test. Nope. We've got two images here. I wonder why I spelled it wrong. Hello world and hello world. Hello world. $64. So, oh, maybe I need to, I'll put it as a different name. So we'll say this is going to be ARM 64. So I don't keep getting confused. Got to the build command now. Build X ARM 64. So I'll use a different tag. Okay. You don't need to put the platform when you're running it, only when you're building it. We'll figure out the rest. So it's just giving me a warning that my host architecture isn't what matches the container, which is fine. And it's gonna, if you choose to continue to run containers like that, they get a performance. I think is what we're trying to get at. So now that I've got that, I'm gonna switch over to WASI docs, and we'll work through the code examples there. So I'll throw this in the chat. This is where I'm getting my material from. A couple different examples for the WASM stuff, but I wonder if the WASI docs have any different. I don't necessarily want to run a web application in the browser and then have it compile and then embed the WebAssembly and some JavaScript. There's more moving pieces there than necessary. Really what I want to do is just run something on a WASI target. So if you recall, if you happen to join us for our previous stream, or my stream with Yosh, we talked about WASI, which is WebAssembly System Interface, which allows you to run it on what you would, we got into some debate about what a host is, but essentially some kind of an operating system. And then so what WASI will do is give you a system interface to call, like open files and make requests and stuff like that, HTTP requests. So that is more what I want to do versus we kind of create some kind of web application that has WebAssembly in it. Let's check out WASI tutorials and see what we got. And they only have Rust, it looks like. I'm curious. It's got to be pretty simple to write the same thing I did in Go for Rust. see here, running from Rust. So let's just work through the Rust one. If I need to and I can't figure out TinyGo, we'll just rewrite the sample project that I had in Go in Rust, and we'll recompile or rebuild the Docker files more accurately. So let's just see what we got here. Let's put a new directory for the WASI tutorial. And see. Looks decent from my perspective, but if anyone hanging around, if that's too small, let me know. I'm gonna go into here and create a new, probably doesn't matter what name it is. So if we go into here, have cargo installed, we have Rust installed, so cargo, new demo, it's telling me. Here's my Rust program. Not sure what this program is doing. Probably printing out a name, usage process. Let's find out. I think it's a cargo run. Some arguments like that. Okay. And output, input file, contents. Oh, okay. So let's create a new here called test. I have no idea what this program is doing. I'm just trying to figure it out. Environment marks collect. Maybe it tells me what it's doing in the C example. Performs a file copy operation. Okay, that's why we need different arguments. What does it need? Greater than 3. So test 2. No such file or directory. I wonder where it expects test to be. Example usage of this. It's a file copy which will show to the compile and run programs. as well as perform a sandbox function. Path to sysrut. Weird. Oh, here's the usage. Okay, so let's just compile it and see what happens. Maybe I'm just not too familiar with the Rust run commands. So let's go back to the paved path here. So we did the demo. We're going to skip the top part because that's written in C. Rust up. Target at Wasm 32. Cargo build. Wasm 32. We should have a WebAssembly module created in target Wasm 32. So ls target Wasm 32. I don't see one. Oh, it's under debug. Demo.wasm. Is that what we're looking for? Yeah. So now we can Wasm time. I probably need to install Wasm time. Correct. All right. So that would be the Wasm time is one of the many or one of the several runtimes for WebAssembly that we can use. So I've not installed that. So let's figure out how we do that. And we're almost at the top of the hour. That's impressive. Looks like we can cheat. Use JavaScript. Sweet. So go back to the WASI docs. No, good. So I'm going to change into the target directory. Debug. Oh, WASI. So that's several layers deep. But now we have our WASM file. So that's the code compiled out into WebAssembly. Now we need to run it. WASM time demo. Didn't install properly. Probably need an export. So tell me. So maybe I just need to through the installer. Weird. Oh, maybe I just need to source it from my CSH profile. Directory, Docker, something. Okay. I just need to reload my profile. Looks like it automatically did that for me. Usage. Okay, so we got some usage. That's cool. Where's the doc I was looking at? Okay, so here's where we can create a file. You need this. We're going to echo whole world to test.txt. Then wasm time. Wasm test.txt, it looks like, and we'll put it in somewhere. Failed to find pre-opened file descriptor, which could be opened. Okay. Well, it looks like that's expected. So now you're seeing the sandbox in actions program is attempting to access a file by the name of test.txt. However, it hasn't been given the capability to. Okay, I wonder if that's synonymous with Linux capabilities where you can add what a program can do on the host operating system. All right. So how do you give it capabilities? I wonder how much help the CLI has. Gesture, grant access of a host directory to a guest. Okay, that makes sense. So wasm time give it access to the current directory and the temp directory, and then run. Well, that's pretty useful. That's very similar to the config files in a Docker image, where you can create different constraints. But I've never seen it like with. I think there are capabilities in there, but I've never messed with it. Most people don't change what the Docker file has access to it because it's giving it a full pseudo file system when it boots up. But in this case, because WebAssembly doesn't need the whole file system, you're going to have to be more explicit with what it is that your application needs access to on the host. I can see some pretty powerful security benefits there, the isolation. So WebAssembly. Now we'll try the test again, and then a new file in the temp directory. Maybe worked. So, oh, it did work. My path's so long that my character's on the other line, I thought it was waiting for me. At somewhere. Okay, that works. Now I wonder how we can compile a Go application of assembly for WASI to run. So if we go back to the docs, I think they mentioned somewhere on here, I think they mentioned Go. Wasm time is available as a Go module. That figured. We'll go over adding Wasm time to your project and some examples to provide what can be done with WebAssembly modules. Okay. I don't necessarily need modules. Go run. JavaScript. DOM. That's not what I'm looking for. Using your compiled WebAssembly in the browser. I don't necessarily need to do that. I just want to compile it. Compile, go, WASI interface. Here we go. Perfect. Okay, so we just add some different build options. So let's try this out. I think it's going to be easier. Preview 1. Okay, so preview 2 is just released. We'll be talking about that more next week. It looks like Go is still using preview 1, but let's see if this works. I don't know what this is. GOSS. The architecture is Wasm. Go build. Let's see if it works. Okay. Okay, cool. So now I probably need to create ARM machine. I wonder if I could spin that up quick in Azure. But that is a good recap. So where do we begin here? If we go back, let's focus on this. The idea here, collapse this and just look at the main file. Oh, I don't want to do that. There we go. That's what I was looking for. Now what I need to test is I've got this application, super simple application. I've got a Docker file for it, but the Docker file requires me to build it twice for two different images. I have to build the AMD and I have to build the ARM. And then when it goes to deployment time, say you're deploying it with Kubernetes, it's going to use that metadata in the packet or in the container image to say, hey, this can only run on this particular host. It is an ARM host or this is an AMD host. And so what we should be able to do, that should be what I do next, is deploy it to both versions of it. Should be able to run with the WASM. So we have the WASM here, which is, one of the benefits of WASM is the compilation target because it's binary output. So it should be able to run on either of those hosts and not need to care about what the operating system architecture is for the sample app. And so, yeah, that's what I'm working through here. I think the easy way to do it, I want to see if I can spin up an ARM virtual machine in Azure to compile it to. But if not, what I'll do, and I think we're at time too. Yeah, we're a little bit over an hour. Maybe in the next one, maybe I'll do a short session tomorrow, but I'll set up a cluster because I believe AKS now has ARM nodes. And so we could deploy this. I don't know how they would deploy WebAssembly to it, but could at least do a virtual machine that is ARM architecture. Let's create a new one. I'm curious if I can. That's kind of small. I'll just do it over here. Where did it go? There we go. That's a good question. I'll look up the SKU to see if there are. Well, I don't think some of things. Okay. Yes, series. VPS. If anybody knows, it's in the chat, if you can if you could do what Docker's doing and create ARM64 VM, I guess I should just pull up my MacBook. That would be the easiest thing. I think it's dead though. That would be the easiest thing. But yeah, if there's any way that you can, I think I found a SKU for an Azure VM that would be ARM. But I'm curious if anybody else has any other ways. Oh, there it is. It's a checkbox in the portal. Check it out. You can see it right here. ARM. It's even easier than I expected it. Gen 2. Probably don't need it that big, but it's going to be torn down. Well, I think that's going to take a little bit. Download the keys. But really the only step left in here for me to do, and I'm sure it works because that's the promise of it. I just wanted to walk through the exercise, is to run the WASM on the AMD to make sure that it runs, to make sure that it runs that architecture. Because I've already tested it on my AMD, and it works obviously. That's the compile once, run everywhere methodology. But it would be nice to see how do you deploy these like you do containers? Like how do they get on? Like is there any kind of orchestration story? What do the artifacts look like? How would I pull in and how would I pull these things in? And that's where the component model comes in. I don't know anything about the component model beyond the name, but that's essentially how you can modularize the WebAssembly and specifically WASM. So maybe my next challenge should be to write some kind of a more advanced program so that way I could at least interact with the host aside from giving it capabilities to modify the file. That was super helpful for me. That's the first WebAssembly that I compiled to, I guess. I didn't even need to write Rust for it. I could even stay in my native land of Go. Good. Opposed to Rust, still learning it, but it's still kind of hieroglyphic to me. But I'll stop rambling. That is going to be a wrap for this session. Again, I'm going to share. I didn't go over the one I shared in the link, so let me find. Here it is, the WASI link. And so that's where I'm staying. I'm staying in the WASI world, where some of the other WebAssembly stuff is more talking about the browser, where you're going to take WebAssembly and put it inside of your JavaScript or whatever it might be. I'm trying to work more on the system side, where you're working, kind of where I naturally fit is, like drawing more mental models to containers. And so I'll continue to do that. Next week, we're going to talk about Preview 2. So Preview 2 comes with a lot of big changes for WASI, WebAssembly System Interface. We'll probably dive into the component model a little bit there, and I'll interview Yash about those questions. But yeah, that's what's up for the next live stream. Thank you for watching, and don't forget to subscribe. Like, subscribe, comment the video. I appreciated all the lively chat in today's session by Matt and Tech Doofus, so thank you for that. And we'll catch you on the next one. I will put them out in advance so you can see this continuation. WebAssembly is going to be an area that I keep diving deeper and deeper into. So you're more than welcome to jump in at any point. But thanks for joining the live stream. Thanks for struggling through the rough start with me, and we'll catch you on the next one. See ya.